All right, everybody, we're going to get started here. And when the food comes, which will probably be 2 minutes after we get started, then we'll have to take a break for the food. But at the interest of waiting, let's go ahead and get going here.
So hi, everyone. My name is Layale. I'm the new Physics Club president. My agenda consists of informing you what the Physics Club is all about, how you can get involved on campus through the Physics Club and through the department, as well as some upcoming events we'd like your help with, and some research projects that you might be interested in. So first off, what is the Physics Club? It's a non-profit club, meaning all the money that we make goes back into the club to improve it and to fix things that are broken, like demos. And we are dedicated to improving the undergraduate experience for physics students. So we're here for students. It's by the students, for the students. So the way we achieve this mission is through community outreach, collaboration with other clubs like Chem Club, providing a support group for students, being a resource for different questions that one may have, like how do I get involved on campus, where can I find help for, say, this class, or what profs should I ask for help in terms of research, or what classes should I take, etc. So it's just a bank of wisdom and experience that students can rely on to get through their undergrad. It's also a great way to get involved on campus through community outreach. And as Dr. Azzi predicted, the pizza is here within 2 minutes of the presentation.
I knew it would make it start.
Sorry, should I leave?
No.
So we'll have pizza, and then we'll get back to the presentation.
We'll resume shortly. And for all you people who are not here, you're missing out on the good pizza.
All right, so as I was saying before break, Physics Club is a great way to get involved on campus, and it's a good way to improve your soft skills, which are things like leadership, teamwork, time management, etc. So in class, you get your technical skills or your hard skills, and then through your extracurriculars, you get your soft skills, which are things employers typically look for nowadays. So these are some events that we've had over last year. This is from Science Rendezvous, which is happening again this year, this Saturday. And this was during Science Academy, where we had a presentation on lasers. It's important to note that they liked our presentation so much that it was the main feature of Science Academy. So over the whole week, of all the different departments, ours outshone everyone else's. And that was only done through the students, like through physics students like us. So the club room is located on the first floor, if you didn't know, room 182-A, right next to the optics lab. And this is what it looks like on the inside. It's very cozy. There's a few game stations in there, a TV, a coffee machine, a fridge that no one uses, microwave, and some tables for studying, and a board to write up problems. So during the fall and the winter, a lot of students are crammed in there, either reviewing for their midterms or trying to work out something together. It's very homey, and it's for physics students. So last year, our executive team consisted of everyone there. My poor, non-existent Photoshop skills are very evident here. So we had Taylor as president, Jake as vice president, Milos and Andrea as treasurer, Brianna as secretary, Doris, who is here today as junior VP, and Alexi as our SciSoc rep. Now, most of these people have graduated or graduating, so that leaves the new executive team. Victor not available for now. But there's me as president, Doris as vice president, Alexi as our treasurer, Emma, who's in first year, as our secretary, and Travis, first year as well, as our junior VP, and Kenneth as our science study rep. So if you ever have any concerns about Physics Club or what you can do, talk to one of these people, and we'll be sure to accommodate your request. So this is our Instagram, UWindsor. This is where we post most of our social endeavors. We advertise our stuff, and we post memes sometimes too, funny physics memes if you're interested in that. Yep. So give us a follow on Instagram. That way you stay updated with what we're doing. As I mentioned previously, we do a lot of outreach events. So these are things that we do in the community to promote physics to young children and people who are interested in physics but never got into it. Sometimes this is what leads them on the path to a physics career. So it's really important that we do these things consistently to perhaps inspire the next batch of physicists. So we do things like Science Rendezvous, which is this Saturday, May 12th. So if you're interested in volunteering for that, please let me know, and I'll let you know the more details about the event. Basically, what you'll be doing are demos, either at the booth that we have at the table or at the Funky Physics show, where we do things like the fire tornado, we pop balloons with lasers, liquid nitrogen demos with the rose, so you like freeze the rose in liquid nitrogen and you just shatter it. We also do things like Science Academy, which is put on by the Faculty of Science for grade 11 going to grade 12 students. This is a week-long camp, science camp, where every day is 2 different departments. So we have one day where it's physics and math, and this is where we do, where last year we did a presentation on lasers and a laser maze experiment, which the students absolutely adored. We also have Science Olympiad, which is in October, and this is a competition with actual cash prizes for high school students across Windsor, and they compete for a day in different science challenges. So last year we had the pendulum golf challenge. So very simple, but very appreciated by physics teachers because they incorporated basic projectile motion physics, which was easily understood by most students and very accurately showed, kinetics and dynamics. So these are things that we do for students, and in the end, it either makes them appreciate physics a lot more than they did before, or inspires them to actually go into a career in physics. Or it doesn't inspire them at all, which usually doesn't happen. So we also do tutorials for some physics and math classes. If you're interested in running tutorials, please let me know. All you would have to do is show up and run the tutorial. You don't have to plan or anything. That will be the executive team. So that's something that you want to do. Just email the Phys Club, and we'll set you up with some tutorials. We also do Welcome Week. So Science Society usually has a lot of events going on, like I Love Science Day, where Physics Club has their own booth and they run demos for all science students. So we also participate in the pep rally, which is held at the Welcome Center, the welcoming celebration. That's where we usually shout off the engineers, and it's a lot of fun. So if you're interested in doing something like that for the first week of school, please let me know. This is also where we go to program orientation and actively talk to the first year students to make them feel welcome, which is always important, so that way they feel like they belong in the community and they succeed and know where to go if they need help. We also have socials for physics students. So we had a fall social last year, and we had a laser tag social as well. My hope is to have more of these socials over the course of the summer and the year, just so that way we can reinforce the community aspect of Physics Club. So please, if we do have socials, try to attend. It's only beneficial for you. It's we don't put these on for ourselves, put these on for all of physics. We also have orientation videos that we do every year. It's tradition. The year before last year, we had the Prof Father, which Dr. Amy started as the Prof Father. And then last year we had National Geographic. I won't show it now, but if you're interested in watching it, I'll send you the YouTube link, just because I want to get going for time. So here's some pictures from our event. So this is from Science Olympiad. This is our pendulum golf poster made by Taylor. This was from our laser tag social event, which was a success. It was really fun. So we have an important event coming up, and we need all the help we can get. So this is for the Science on Tap series, Light and Libations, put on by the physics department. Dr. Azzi would like us to run some demos, so if you're interested in participating, please let me know. You do have to be of drinking age to attend. So you'll be doing things like the water bucket light guiding experiment, blowing up balloons inside balloons, which Dr. Azzi did on the Daily Planet. It was a pretty cool video. So you have like a transparent balloon, and then a darker balloon inside, or black balloon, and you can pop the balloon inside without popping the outside balloon. Really cool. And we'll also have the diffraction grading glasses, which we have a bunch of, which we'll distribute, and then we'll have the discharge lamps where they can view the light through the glasses and then see cool things. So this is a video with starring Rob. We have selective. There. So he has a laser in his hand, and he pops the balloon with just the laser. And there he is, sad that he popped the balloon. So we did this at the Optimist Group event in the Forest Glade Arena. So this is something that we do also over the year with Let's Talk Science, which Michelle Bondy also runs. So we sometimes are asked to put on a funky physics show, and we go to the Let's Talk Science event, do our show, and then we leave. So it's like, it's a really good way to do physics outreach with little commitment and lots of fun. So if you're interested in participating in the event as a volunteer, please email Dr. Razzi or the Fizz Club, and then we'll just send your name off to Dr. Razzi. You do, again, have to be of drinking age to participate. And I'll send out another email after this event as a reminder, in case you forget. It is happening May 24 from 7 to 10 at the Walkerville Brewery.
But I don't think people who are working at it won't have to pay the $10, by the way.
Okay, I didn't know that. That's good.
I wasn't sure either. I didn't think about it, but Dr. Rangan asked me. So if you're coming to work there, I'm not going to make you buy a ticket for $10. Right? But I mean, if you want to get a beer, then you have to pay for your own beer.
So if you
So don't let the $10 tickets dissuade you. It'll be free if you're doing something.
yeah, so if you're just gonna go to watch, then you have to pay the $10.
Does your ticket will include beer?
One beer.
So if you volunteer, do you get a free beer?
You do not.
Okay, that's what.
Okay, so volunteering is not the only way to get involved on campus. More important than that is research. It's very, very important if you're considering graduate studies, because that's typically what they look for in applicants. Getting involved as early as possible is the best way to get the most experience as an undergraduate researcher. So typically from after your first year, you can get involved in a lab. But it's on you to do this. We can, tell you about profs all you like, but you have to be the one to get up and go talk to the prof. Most of the people in this room have already done this, but it's not a bad idea to reinforce this concept, and so that way when you talk to first year students, you let them know that this is the procedure we have. So after this slide, I'll ask Michelle to talk about the internship course, and then I'll ask some of the profs here if they want to talk about their research. So if you are interested in doing a research project as a course credit, you can do that through the internship class. If you're interested in doing community outreach as a course credit, you can also do that through the service learning class. They do depend on the number of enrollment, so they don't always run. I'll have Michelle Bondy take over for me at this point, because she has way more information than I do.
Thanks, Layale. I gotta make sure I'm gonna be on the screen here. All right, I'm good. So thanks for inviting me to your meeting today and letting me give a plug for my courses. How many of you have heard of the internship and service learning courses already? Wonderful. Okay, so I guess you did get the email that Dr. Bazzi sent out, so that works, Steve.
Good.
The courses are very similar in how they're structured. The main difference is the type of placement that you'll be doing, as well as some of the learning outcomes, and that determines some of the topics of assignments that you'll submit to me. So generally speaking, I'm just going to talk about them kind of combined. If you have questions about each specific course, feel free to ask me. So as I mentioned, the difference between the placements is, as Layale pointed out, so service learning is more for community outreach. Examples of placements that you could do through a lot of my outreach programs that I organize. So Let's Talk Science, I've had lots of students do service learning through Let's Talk Science. Science Rendezvous is another option. Sometimes it determines which semester you do the course in. So obviously Science Rendezvous is this Saturday, so it wouldn't be appropriate for you to do a placement through Science Rendezvous in the summer, but in the winter semester it's a great one. We've also had just service learning through the departments where Dr. Razzi kind of partners with a high school directly, and then a student goes out and works with that high school. That's another option. It doesn't just have to be through my own outreach programs. And sometimes service learning is also just off-campus placements with local nonprofits or that sort of thing. There's also opportunities on campus. I should make a plug through service learning. Do you all know about the USI network? Some of you do? Okay, so there's a USI space up on the 3rd floor of Essex Hall. in room 335, and we're developing a network for undergraduate science students. And we've had placements through the USci network through service learning so that students can kind of get involved in the network and help us develop projects that are going to benefit all undergrads. It would be lovely to have physics students give their input on that, right? So those placements are open to students in all 8 departments. Last semester we had 2 students, one from biology and one from environmental science, kind of give their input. It would be nice in future semesters that we would have, say, a physics student and a math student or a chemist or something like that, so that we kind of get different viewpoints from different departments over the years. So if you're interested in doing something where you're more kind of developing initiatives for students through the department and through the faculty, that's another option through service learning. Mostly we'll talk about internship today because I think you're all mostly interested in doing research, and that is the most appropriate option for research is through the internship course. Internship could also include off-campus placement, so if you know of a physics-related company that would be interested in hosting a student for an internship, that's another option as well. But many students will do the course through an on-campus placement, I should say. It's basically all placement-based, so you have to do at least 9 hours a week towards your placement. A lot of people ask me, does it have to be exactly 9 hours a week? No, it can vary as long as it adds up to a total of 108 hours by the time you finish your semester. So if you do 3 hours one week and 12 hours the next week and 17 hours the week after that and then 0 hours, that is absolutely fine. As long as you're communicating with your placement supervisor, who's not me, so I don't need to know your weekly schedule ahead of time or anything like that. Just communicate with whoever your supervisor is for the course, and that way they know when to expect you, but it doesn't matter to me how you schedule your hours. You will submit bi-weekly assignments to me, roughly bi-weekly, where you'll submit your hours that you have already completed, and that's just to help me make sure that you're on track to completing your hours so that you'll get the credit for the course. But, for instance, do I need to know that you were sick on this day and you were supposed to do hours? No, you should be emailing your supervisor so that they know not to expect you. The communication should really be through your supervisor for all of those details. The 9 hours a week includes at least 3 hours where you're on site at your placement. So assuming you're working in a lab, that's at least 3 hours in the lab. I know the reality is it will be much more than that, and that's absolutely okay. As long as you're meeting the minimums for the course, it doesn't matter if you do double the amount of hours that I require. As long as you and your supervisor agree to it, that's fine with me. I think I had a student do over 250 hours in the winter semester, and that certainly wasn't required. It didn't change the grade in any way, but obviously it helped them get a good evaluation from their supervisor because their supervisor was very pleased with their work. So the 9 hours could also include things like submitting your assignments to me. That's part of your coursework. Any emailing you do back and forth with your supervisor or anybody else in your placement that you need to do. So it's kind of all-encompassing, those 9 hours. The best advice, and Layale, I heard her talking about this when I came in, keep track of everything you do. Like, just keep a notebook where you keep track of everything you've done for your placement because you will forget. I barely remember what day today is. I'm not going to remember what I did last week on Monday and Tuesday and Wednesday and so on and so forth. It's just a good idea to keep track because it will really help you when you're submitting your assignments to me. And at the end of the year, you have to submit a final report, or at the end of the semester, I should say, and you'll want to keep track of everything that you've done so you don't have to go back and try and figure it all out again. So keeping track of everything, and you'll submit, a summarized version of that to me bi-weekly with, the hours that you submitted for that week, and I'll have a topic for an assignment that you submit to me. A lot of people have questions about the assignments. They're pretty short. Some people said it was a lot of writing, but I tried to keep it pretty short. So they were usually 2 to 3 pages double-spaced at most. There were 5 short assignments that they submitted to me and then 1 final report. The idea is that the short assignments actually lead up to the final report. So I was trying to trick students into working on their final assignment throughout the course. Once you get to the final report, the idea is that you can put in pieces of the earlier assignments into your final report, so you're not starting from scratch at the end of the semester. So it seems like a lot of writing, but a lot of it can be used towards the end. And then you also get feedback on your writing all the way through because I provide feedback on each assignment. So it's meant to really kind of support students who might not be used to reflective writing. Some of you are just so used to writing lab reports. It can be harder to write about how you've worked on your interpersonal skills or how you've managed a conflict situation or collaborated with others or worked on problem-solving skills and that sort of thing. And that's the kind of the soft skills that we really want to focus on in this course when you're submitting assignments to me. Obviously, you're also gaining technical skills through your placement, and your supervisor will evaluate you on both your technical and your interpersonal skills. But through the reflective writing, I really want to see how you're growing as a professional and how you can connect what you're doing in your placement to the other courses you've taken. And that could be courses in physics, but it could also be courses in math or in communication studies or French or whatever other courses you've taken on campus. What have you learned in those courses that can connect you to your current placement, and what has helped you in your placement from your prior knowledge, and what was completely new for you in your placement that you can then take on with you as a professional when you're applying to grad schools or professional schools or whatever it is. So that's what I want to see in those reflective assignments. So I talked about the assignments, the report, the hours. Your supervisors, once they sign you in to the course, they're responsible for completing a midterm and a final evaluation for you. So it's a 2-page document, and they're just going to give you a mark out of 50. The course is a pass-fail course. That's an important thing to mention. So on your transcript, you will either have a P or an F, probably a P. I haven't failed anybody yet, and I don't plan to. The course is meant to be, I don't like to say it's an easy course. I think that there's a lot of work that goes into it, but there's a lot of support built into the course to allow people to succeed. So I don't have any reason to suspect that any of you will fail the course unless you absolutely don't go to your placement or don't submit any assignments to me. To pass, you have to get a 70, so it's not a 50% pass, it's a 70% pass, which means on your final evaluation, you need to receive a 35 out of 50. That's a pass mark for the evaluation. So your supervisor submits those to me or to you, and then you submit them to me if they show them to you first. And that's a big component of your grade along with the assignments that you submit to me. Is there anything else that I'm missing about the courses? I look at Layale because she took them. She took one already. They are offered hopefully every semester. So I'm a sessional instructor, which means I apply to teach them every semester. So I can't 100% say that it will be offered every semester, but if they post it for me to teach, for me to apply to teach, I will certainly apply to teach it every semester and make it available if that's up to me. And this semester, right now, both are available. I do have to have a certain number in the courses for them to be able to run, and that decision is not necessarily made by me. So hopefully we get people registered to make sure. I have a feeling at least internship will run this semester, and then we'll see about service learning. But in the fall, they should both run. I had both running in the winter. I had about 20 students in each course, so that was fine. Does anybody have any questions about the structure of the course, any types of placements that you could be doing?
Are they limited to a single time or?
A single time in what sense?
So I know like special topics will count as different credits, or they'll essentially repeat the credit.
Yeah, so that, to kind of answer your question, you are allowed to take these courses twice, and that could be 2 times of internship, two of service learning, or 1 of each. And that is allowed to satisfy degree requirements. So I know in physics you don't have a science category, so these fit as any other course, if I'm correct. So it won't be a physics credit. It's going to be in the other category for you all, but you can take them up to 2 times. Because it's placement-based, I mean, you can be working on different things in each semester and still get the credit twice. That's not an issue. If you want to take both and you're looking for something in service learning, by all means, so I'm going to make a plug for all my outreach. Layale did a great job, but if you're interested in developing a physics activity for Let's Talk Science, that would be fantastic because I currently have 0 Let's Talk Science volunteers in physics. And I'd love to get more physics offerings. And these are mostly grade school level that we develop for that. So I've had students through Let's Talk Science in the last semester. They were mostly in biology, but they worked on developing a manual for a workshop that we can then build and then have it go out into classrooms and reach more youth with different activities. It would be great to have physics. I know grade school teachers love having physics activities in their classes because they find it kind of intimidating to teach on their own usually. They don't typically have science and or physics background, so they love it when our volunteers can bring physics activities or math or anything like that. Computer science, if you have a minor in that, that would be fantastic. Science Olympiad would be harder to give you a service learning credit for that. We could probably do a combination thing where they work part on Science Olympiad, part on Let's Talk Science, then we can get a credit that way. The important thing for me when I'm looking at a placement and deciding if it's appropriate for the courses is, will you meet the learning outcomes of the course? And are you doing something that is sufficient for a 3rd level course? So I don't want anybody to just be sweeping floors or answering phones or pouring water at a hospital or washing test tubes. I mean, washing test tubes and cleaning a lab is always part of a health and safety requirement for any lab member, but it shouldn't be 90% of what you're doing. You should be involved in the science, learning about the processes of the lab and learning about, how research is done and being involved in that process. That's the most important thing when we evaluate that. And it goes to the Associate Dean for approval after I sign off. So I'm not the final say on that one. If nobody has any other questions?
Is it only for 3 credits right now?
Yes, the variable credit is not an option currently.
It would, yeah, I think it will be once there's more people in the program.
So right now the trick is you have to open up a different section for every type of credit available. So that would mean there'd be 6 sections between the 2 courses. And as much as I would love for them to pay me to teach 6 sections of this course, they don't seem to want to do that yet.
Yeah.
So yeah, I think you'd have to see the numbers, and then you could open up those sections, and it wouldn't be an issue anymore. So for now, it might still say it on SIS. We have applied to change it, but it has to go through a lot of Senate bylaws just because it was confusing some students about how it was being offered. So for now, it is just a regular 3-credit course, the same as anything else that you take. And we'll update you if that does change at all. I have the course package for both courses here. I can pass these around. If anybody wants to keep it, pass it around so everybody can see it, but then I don't have to leave with these. And then if you want, you can also email me and I can send you the digital version of this. My email is right there. And I'd be happy to share more information about these. If you come up with a question tomorrow or something, feel free to email me. I can sign people in until Friday. Technically, the course started today, but the final date to change courses is this Friday, so we can still get you in if you're interested.
Thank you very much. So that's all from my end. Now,
So let me add my bit of what I know about this. So for the department specific things, for the service learning idea, like Michelle said, Layale has done one of these. I've got a list of ideas that I have on the bulletin board outside, so I'm hoping as the year goes by, people who do it, I'm going to be advertising their thing that they did, their event, their class, their experience on that blue experiential learning bulletin board. I've got a list of ideas that I hope people will look at and say, oh, that sounds neat, I would like to do that. Dr. Bayless has just given us some information. So Dr. Bayless is the head of the Science City Museum. He just gave me a list of 6 Science City summer jobs for 2018. There's a total of 6 summer placements for post-secondary students. All positions pay minimum wage of $14 an hour. These would be perfect for maybe internship or service learning. It depends. Because some of these are administrative assistants, but some are vertical farm and STM exhibitors. So you would have to work that out with where exactly. But it's going to be one of these things because you're working in a science museum.
As long as there's a connection to their courses, absolutely.
Yep. So I'm going to hang this list of stuff up on the board outside as well, because we always, in my list of stuff that I have on the board, I'm working at Science City has always been one of them, because that would be a great outlet for some of our students to be doing. And other things are just service learning around the department as well. In terms of the credits, right, so the question that people are always asking me, so I said it in an email, but let me just say it once again. These will go into one of your any requirements, right? So like Michelle said, we don't have science requirements in physics, but you have either 5 or 7 courses where it's like any course goes into your degree audit, and these courses will substitute that. But I was talking with Dr. Dutton, the Associate Dean, about this the other day. So like Michelle said, so the average, say, internship is 9 hours per week, okay? Like the NSERC USRA summer students that I have, they're working 35 hours a week in the lab for 12 weeks. It's a full-time job, right? That's standard for NSERC USRAs. It's a massive amount of work. You do that kind of work, I am more than happy to put in a DARS exception for you to actually have this count as a physics 300 or 400 level class, right? So that's different than your any. On your degree, it says you have to take like 5 300 or 400 level physics classes. I will happily write an exception to accept you from one of those physics classes, and Dr. Dutton has already said he agrees that that is completely equivalent to a 300 or 400 level physics class. So that's not for every placement. That would be, we would actually have to look and, were you doing, is this now equivalent to what a 300 or 400 level physics class is? So the bar for that is much, much higher. That has nothing to do with Michelle's program at all. You're going to get credit for this. This is just, can you convince us that it should take the place of a physics class? But what a student does in any one of our labs, 35 hours a week in a physics lab over the summer, is completely, it's more work than you put in your classes over the course of a semester. There's no doubt about it. So where it goes in might be variable, but I thought that's a really cool thing. So we really hope students buy into this program because you're going to save yourself, you can save yourself some courses and get research credit that you should be getting. So where it goes, we're not exactly sure, but talk to me about it. That's what I know about it right now.
That's great.
So yeah, it's really good. So if you're doing these things anyways, as I keep saying, if you're already doing them anyways, you should be getting the credit for it. Because why not? You're not doing any extra. Okay, you have to do Michelle's extra work. But if you're working 35 hours a week already, what she's asking is small compared to that. That's the point. You're already doing a ton of work. So I keep telling people for a little bit more work.
The assignments aren't like lab reports or anything like that.
No.
They're pretty straight. It's like journaling, basically.
So take that.
I can attest to that. It's not, well, as long as you don't leave it for the last minute, it's not a lot of work. So don't leave it for the last minute. So that's all from my end. Now, if professors have a bit of a blurb they want to say for their research, if they're willing, please come up. I think Dr. Kim's presentation is already on here, so if you'd like to start us off.
So my research is, big overview could be described as collective phenomena in condensed matter systems. So what does this mean? So in a condensed matter system, we're interested in materials, and here you have order 10 to the 23 particles. And these particles, they interact with each other. So when you combine the interactions between the particles and quantum mechanics, one can get very beautiful types of behaviors, which has eloquently been described as a quantum waltz. The things that I've been focusing on for the past several years is atomic scale engineering and entanglement characterization of exotic phases. So admittedly, I haven't been doing much with this recently. I was doing quite a bit with this with my former student, Brendan Rhino, who graduated. When he left, this kind of took a back seat, and most of my time is spent on this. So very briefly, what do I mean by these? So with atomic scale engineering, the traditional approach of fabrication is so-called top-down. So basically you start with a piece of material and you etch away stuff, leaving a final product. What we're interested here with atomic scale engineering is a so-called bottom-up approach, where we build a system rather than starting with some bulk piece of material and carving away. We build a system from the fundamental building blocks, and in this case here, we're interested in building things one atom at a time. And our motivation here is this provides a novel means of controlling and transmitting information at the smallest of scales, namely using atoms on surfaces. Okay? So here are a couple of examples that we looked at. So here we were interested in signal control, and another thing we were interested in is if information transfer using a collection of magnetic atoms. Okay? All right, so with regards to entanglement characterization of exotic phases, let me first tell you what I mean by exotic phases. So this means different things to different people. For me, I'm particularly interested in phases where the fundamental degrees of freedom break apart. So what do I mean by this? So it turns out in one-dimensional metals, so if you combine electrons to one dimension, okay, so we all know that the electron has charge. Okay, that's what's allowing me to give this PowerPoint presentation. But the electron also has a degree of freedom called the spin, which I believe you first encountered in your chemistry course. And it turns out in one-dimensional metals, the spin and the charge will look like it breaks apart. Okay, so if you measure some property of the electron, it looks like the spin and charge are moving independently, like the electron has broken apart. And furthermore, the electron operator, the object that creates or destroys an electron, is described by this combination of so-called vertex operators. So that name actually comes from string theory. So the actual mathematical machinery to describe these one-dimensional metals, rather amusingly, the appropriate machinery to do it comes from string theory. Okay? Another class of systems I'm particularly interested in is certain types of superconductors where it looks like the electron has broken in half. The electron has broken in half. So here, the electron spin and charge they move independently. Here it looks like the electron has literally broken in half. Okay? And I'm interested in characterizing these systems using entanglement. So entanglement, essentially, well, paraphrasing Einstein, expresses the spooky non-locality inherent in quantum mechanics. So this is something that really, really bothered Einstein. Okay, so what is this? So in classical physics, if you have a system that is composed of two subsystems, A and B, so if you have two boxes, how do you know everything about the composite system? Well, if you know everything about what's in each individual box. But in quantum mechanics, there's more to the story. Very simply because of superposition in quantum mechanics, well, there's a lot more that can happen than just having things, well, specifying what's in box A and what's in box B. Okay, so a sample of some of the things that I'm currently working on. So, well, when I put together this list, these are the things that, you know, are basically eating up my existence. So one thing that I've been spending a lot of time on is characterizing disordered so-called Majorana wires. So these are superconducting wires where it looks like the electron has literally ripped itself in half. And, well, so one possible use of these exotic wires is in quantum computation, a certain way of doing quantum computation, namely so-called topological quantum computation. And here I'm interested in the effects of disorder. So for all of you who work in labs, you know the first and foremost thing you try to do is keep things as clean as possible. Well, it turns out when you actually have dirt in the system, so I mean, dirt is inevitable. Okay, so you can't make things infinitely pure. Dirt is inevitable. Now, in certain situations, dirt, the stuff that you try to avoid, actually gives rise to exotic behaviors. And it's known that in this system, well, that's what happens, and I'm working to characterize this using measures of entanglement. Okay? Another thing, well, that I'm very excited about, and this is a collaboration that has emerged with Professor Hawk, is entanglement in spacetime. So John Wheeler, who I've introduced to you, he was Feynman's thesis advisor, and he also coined the terms like black hole, wormhole, quantum foam. Those are all due to him. So for a big part of his life, he worked on Einstein's general theory of relativity, and during that period of time, he said everything is geometry. Toward the end of his career and also his life, he worked on the foundations of quantum mechanics, and there he, well, started thinking everything is information. And, well, it looks like this, well, this is true, and, to an extreme that Wheeler probably never even envisioned. Namely, there's a picture emerging that the fabric of spacetime, if you will, is formed from entanglement. Now, I'm not trying to go at that big question. Professor Hawk and I, we are trying to address something a little bit more, well, not as big, but something very interesting. Namely, there's some paradox, some subtleties going on with certain types of field theories and their geometric dual. So we're trying to understand some peculiar features looking at certain types of toy models. Okay, so like I said, I spend most of my time thinking about entanglement, but I have some other things going on. So this is a problem that's been on my mind for a number of years, namely pattern formation in the driven two-dimensional electron gas. So pattern formation is ubiquitous in nature. So for example, in windblown sand or shaken oil on a surface, you get, well, as you can see, patterns emerging. Another example I came across, which I found a little bit gross, but here's another example, namely a mold colony, when it develops, will form this kind of pattern. Now, it's been found that if you take a two-dimensional electron gas and drive it with an AC field, all evidence seems to suggest that you get various types of patterns emerging in this system, and this is something that I want to take a serious crack at. So this is something that I've been interested in for a number of years, and I think I finally have the machinery to actually go at it. So, well, during my sabbatical, this is something I'm going to pursue quite strongly. And finally, here's another example of something I'm working on, I'm involved in, namely random matrix theory and its application to HIV. So there is a paper published, it's a collaboration between MIT and Harvard, where they use techniques developed in physics, namely random matrix theory, and they argue that by doing this, they found an Achilles heel in HIV. And, okay, so I found this fascinating, and working with a couple honor students in the biomed program, well, we're trying to do something with this. Okay? So, all right, so I guess this is a talk about research opportunities. So these types of things, like characterizing disordered Majorana wires and entanglement in space-time, okay, so these are not things that I can just easily pass off to a student. So, well, at least something like this is both Professor Hawk and I really banging our heads at this. And, well, okay, so we're still trying to flesh certain things out. So typically in my research, once I have things well-defined, then maybe I can pass off some small tasks to a student. This certainly is not in that spot, and neither is this. This project here, this is actually student-driven. So I just showed the students how to utilize techniques from random matrix theory, and they're basically running with this. So this is, at least for me, kind of a fun project in that, well, as compared to these projects, which caused me infinite pain and grief, this has been more on the fun side. So typically my work involves, frankly speaking, rather heavy types of things, and I can involve a student later in the project when I have things figured out and I can assign some smaller tasks. Again, this one here is student-driven and hence fun for me. I don't know how long this one's going to be going on, but again, so with this I'm collaborating with 2 honor students in the biomed program. So that's a quick overview of the types of things I'm interested in.
Thank you very much. So if anyone else, professors or researchers who are here would like to speak on what they do?
I don't have PPT prepared.
No.
Okay, just a few words. My research is more accessible than Dr. Kim's theory, but we do have a lot of fundamental physics simulations and calculations in collaboration with Dr. Kim now. Layale is currently working in that project, so I have currently 6 undergraduate students doing research with me. So my lab has 2 threads of research going on. One is with the convention. Most of you have been to the 370 class, so you know about MRI already. And the fundamental difference between MRI and other medical imaging methodologies is complex. Because for CT, you just have an attenuation map, that's it. You don't do much with it. You just get an image. But for MRI, the very complicated information comes from other MRI parameters like T1, T2 relaxation. And those will give you much more powerful information about tissue and pathology and whatever information you're looking for. So I'm more interested in quantitatively defining those parameters and interpret the information correlating with the physics behind it to show tissue properties and really correlated with whatever condition patient might have. So one part of the project was to use a conventional MRI scanner for rats that's for a small animal machine, which will be in place by the end of the summer. And in collaboration with biology researchers and other researchers from chemistry, earth environmental science, so they have their own interest in studying their sample. So the biology people might be interested in the brain, how it changes with responding to certain conditions. And I would tell them those information based on how T2 changes, how the fusion changes, with a spatial distribution of the information. And the other part of the research is to build my own portable scanner that's been going on so far. And we have electromagnet as a prototype for the portable MRI, and also next stage we'll be designing a small permanent magnet. And we have purchased our own spectrometer. Then there will be a lot of hands-on experience building coils, building gradient sets, and building the magnet, so put everything together. The idea is instead of pursuing a very, very expensive medical scanner, you could have the similar information, if not better, by these cheap stuff but with more complicated signal models and signal processing. And in the end, that will largely increase the accessibility of MRI in the medical society in general. So, and yes, I will have an MRI class in the fall. If you want to learn more about it, you're more than welcome to come to that class. There will be no exam in that class.
No exams.
So is there anyone else? Okay, I think that's all for today.
Oh, I'll go.
Oh, Tracy?
And I'm going to have these guys go too, because there's representatives from the other people. But for the people at home, let me just make a list. Because it's important that people know these are all people who do want researchers, the students to come.
Right.
I mean, we're waiting for people to come and ask us to do something. So Dr. Kim, definitely. Dr. Xiao. I'll talk about myself, and then I'll have Dr. Delaretto come up and quickly, although he didn't know he was going to, but he'll speak on behalf of Dr. Rankin, and Dr. Sadler can talk on behalf of Dr. Maev, and Andrew can talk. Just so everybody gets fair shake, I think. So yeah, so I'm Steve Raisey. So yeah, I don't have any. None of us are really going to talk too much exactly about what we're doing. So I work on pulse laser based applications for mostly in biomedical systems. So yeah, I'm always interested in having like 5 or 6 undergraduates working for me at any one time, and that's over the course of the year and through the summer as well. So there's always a lot of activity going in there, and people are either growing bacteria and blowing bacteria apart with our lasers, or we're doing fundamental probes of the laser plasma interactions. We're trying to understand the physics of what happens when we shoot our lasers at materials, or then shoot our lasers into the plasma to re-excite the atoms in there. So there's just lots of opportunities for people to come and contribute right off the bat. So I should say for most of these, I don't know what people think research is like. We understand you don't have experience when you come. I think there's kind of a hang-up some people might have. I don't want to come. I don't know anything. Like, we know that. When you come to a lab, most research groups, you don't know anything that's really relevant right then. We'll teach you. That's fine. So just, you don't have to be afraid to just say, I want to do something in there. You just have to find somebody who's doing something interesting. So all these pulse laser experiments, my expectation is, if you put in a couple years working for a group, I mean, I'm sending most of my students to conferences now, so I want to pay to send you somewhere, which will really help your career. I fully expect you can be a co-author on a publication by the time you graduate an undergraduate degree. So these are entirely achievable goals, and they'd be really, really important for career progression. So that doesn't happen right away, but it absolutely can and should happen. As we move forward. So. And I'm excited to have all the students who we've been having do research. I'm hoping some of them can also be starting to get some of this research credit through Michelle's high impact classes as well. So we have a pretty good time. Yep, there's always lots of Game of Thrones discussion going on up in my lab. Before we get to the serious work of physics, like, we have to parse Game of Thrones first every week, and then we can get on to the realistic stuff. So we have some other professors who are not here. I'll just have Dr. Sadler come up and just. So Dr. Maeva is on sabbatical right now, but when she returns, I am sure she's always got a bunch of students kicking around her lab. So she's usually looking for students. So I'll just have Jeff. He can, of course, not speak to all of Dr. Maeva's programs, but he's been in the lab with people doing those things. So I'll let him just briefly describe it.
Of how hard Dr. Maev and Dr. Maeva are looking for someone, specifically since she's been on sabbatical for a while, and I haven't talked with her lately, but generally we have biological projects, biomedical, material characterization. Andrew, anything else?
I can give it.
Yeah, no, off the top of your head. But in the past, we've had the physics and high technology people come through co-op. If you're worried about not being qualified high school students, so it'd probably be best to email Dr. Maev and Dr. Maeva to see, since it's such a large group at some points, who is there, who has room, and who, since they're rather busy, who to talk to of each kind of subgroup who would be supervising it. And yeah, since they said research is good for you, I guess at least 2 of my students are on previous hires are off getting their PhD. So there's influence. And it's something you won't get at a lot of universities.
That's a good
So,
point.
so Andrew, do you want to?
I worked for 4 months, and that was it for a professor.
So another one of the professors that isn't here is Dr. Maya, who has a small army of students floating around, I think,
Yeah.
somewhere. So
So Dr. Maya does research particularly in the materials characterization field. So in that way, we're doing materials development. So we have cold spray projects. So if you're not familiar with cold spray, essentially you're shooting metal at high speeds, and it actually bonds at a solid state level to a material. So you can basically 3D print or build stuff from metals and other materials using that process. And my particular research is ultrasonics. So we do ultrasonics, thermography, and I think we're trying to build a few other methods, but these are all under a field of non-destructive testing. So very similar to medical imaging, we use a lot of the same principles. So you'll just be basically using your undergraduate physics and applying those to imaging. And the big difference is when we're imaging a sample, we can use techniques that medical imaging can't, or at least operate in regimes that medical imaging can't just due to health and safety. So when you're talking that, in that field, we mostly do ultrasonics and thermography, but there's also radiography, neutron imaging, there's X-ray CT. So there's a lot of overlap there. So I would say if you're interested in medical imaging, it might also be a good option there. And we particularly do, like I said, ultrasonics. So if you want to go that route, it'd probably be the best. But there is a lot of other options to stream into or branch into, I would say.
Oh, thank you.
Sorry, question? No.
and Chris. So the last person who's not here is Dr. Rangan, and Dr. De Loretto has extensive knowledge of what goes on in that lab. I should point out that Dr. Maev, for people who don't know, Dr. Maev runs the Institute for Diagnostic Imaging and Research. So Mark Armstrong, who's here, is like just going to be working there over the summer. You don't see a lot of those students here. So you think, oh, I don't know what they're doing. That's because they're the only people who are in a different building. They're not on campus, right? But they're still part of the university. They're real students. I mean, first-year students might not know that. They're part of the university. They're part of physics. They can be in these internship classes. It's just not in this building.
I
So you
have
don't see
2
them. Yeah.
this semester in IDIR.
Yeah. So just take that for what it's worth.
So take this with a grain of salt. I don't exactly know what the specific research plans are, but I can give you a general overview. So what we typically deal with is quantum optics, or optics of nanoscale devices. So basically we're looking at how light interacts with things that are very, very small. In terms of research streams, in the last couple of years we've kind of spread out a little bit. So working in the Rangan Research Lab, you can do something involving optimization of nanoscale photonic devices. And for an undergraduate student, surprisingly, even though it sounds hard, it's incredibly easy because we paid a good amount of money for excellent computational tools. And I believe it was Sam scripted them so that they are hilariously automated. In fact, if you ever remember Hassan, we actually replaced what he used to do with a script, which we named after him, because it's like him but faster. Well, it does, 100 times the amount of work in the same amount of time, because he figured out what to do, and then we just took what he did and just said, okay, computer, you do with this. If you don't want to go with the more classical nano-optical approach, we've actually been doing a lot of research in quantum optics and pure quantum optics, with the idea being if instead of just shining a laser on a system, you have a very, very strong, very, very rapid pulse, you can get some crazy optical properties. Because if your pulse is fast enough, your electrons no longer oscillate as simple classical dipoles, which means all the classical EM in your textbook is very, very different. And we use that to figure out how systems work, break down a complicated system into nice, simple approximations that you can use in a reasonable amount of time. And we actually look a lot at different experiments and different optical techniques that come out of these pulsed systems. And I figure we're going to do a lot more of this because I believe the new hire does experimental research in that exact field. So it'll probably line up pretty nicely. As for that one, again, computational tools, I wrote them because my pet peeve is lack of documentation. There's actually a significant amount of documentation for you to use. So it's relatively straightforward. Most of the groundwork is already laid. I believe as a research thing, we just need somebody to actually sit down and do it. and figure out what kind of systems to look at. But yeah, that's about it.
Thank you very much.
Then let me just put in a plug for the two people who aren't here then. Dr. Drake. Dr. Drake is retired. He actually, I think, has the largest research group in the entire faculty. He's got more graduate students than anyone else, and he's retired. The guy should slow down, but he's not gonna. So the point is, he's still taking students to do work. I think the new, I know at least one new undergraduate who's going to be starting work with him. So you should completely, if you want to do theory. So Dr. Drake does high precision atomic theory calculations. That's what he's known for. So a lot of people go to work for him who want to do high precision calculations. Really good quantum mechanics, atomic theory. And as Dr. De Loretto mentioned, then Dr. Hammond, I'll just mention him because maybe by the time people watch this video, he will be here. He's coming on July 1st. He'll be our newest hire. He works on femtosecond laser pulses, strong field laser matter interactions, what Dr. De Loretto was talking about. So he'll be shooting very short, very intense pulses of light into crystal materials and then looking at the weird properties that happen from there. And having talked to him, I know for sure he'll be interested in having students come work for him, right away as soon as he gets his lab up. So Dr. Zhao can comment on that. It's not immediate right away, but it's pretty fast. How long did it take for you to get your first student who's just like right away? John Mark was working for you
September.
Yeah, so it was like she was there 2 months and had a student work for her. So if in September if people want to work there, they should think about that too.
Yeah.
So I'm pretty sure all these people would be looking for student help if you asked them, and would be eligible for this if they know about it. So part of the point of this procedure was so it's entirely possible now you as a student may know more about this program than these people do. Do not be deterred.
Just give them the course package and my email.
So
and I can fill them in.
You might have to tell them, I really want to do this, and they'll look at you with this blank looking like I have no idea what you're talking about because they weren't here. So Dr. Kim was here, Dr. Zhao was here, so we'll know what you're talking about. The rest of them, no problem.
Rebecca and I just set it up so she can do this internship in Germany and get credit, right? Yep. So I've been emailing documents to Germany and we've been able to sort it out. So it's not a barrier if they're not familiar with it.
All right, so if there are no questions, I think that's about it. Thank you very much for coming out to this presentation. I hope it was useful or informative in some way. If everyone watching at home, next time you better come for the pizza. But I hope this presentation helps you decide what you want to do for your undergrad, because it is important that you get some experience outside of the classroom while you're here. You pay a lot of money to study, but that's not all that goes into your 4 years of undergrad. You will learn a lot of life skills, and this is the time to get them, so that when you graduate, you can go to grad school or get a job, etc. So thank you very much to the physics department for sponsoring us with the pizza. And thank you to Michelle for coming out and giving a talk on the class, and thank you to all the professors and researchers for coming, talking about what they do in the lab. I'm sure everyone really appreciates it. So with that being said, thank you, and hope you have an excellent summer.